Let's talk for a little bit about some linear equations that are linear equations, but they might look a little bit different to what you're used to, but they're not that freaky. Here's one, y equals 3, or here's another one, x equals -2. Now, I know that they're linear equations because the highest index for any of those pronumerals is 1. There's no x squareds or x cubes. There's only an index of 1, just x on its own, or y on its own. So I know that they're going to graph linear, but they look a bit different. So let's just talk about what they look like when we graph them. They are both linear equations, and I want to have a look at this one here. I'm told, let's just focus on the blue one for a minute. We're told that y equals 3. So I'm just going to put a little point there. Here we know that y equals 3, because this is the y-axis, and this is the point 3. So when y equals 3. What if I went along a little bit here? So I'm moving along this direction. When x equals 1, what does y equal? Well, we're told y equals 3. It just equals 3. What about when x equals 2, what does y equal? Well, y equals 3. That's what the equation says. What about if I came down here to x equals -4? What's y equal? Well, 3. Duh. We're told y equals 3. So what that means is it doesn't matter what x value we're given. Y is always going to equal 3. The equation just says y equals 3. And you can see along this line here, anywhere along here, the y value is always 3. It doesn't go up, it doesn't go down, it's just always 3. So that is the line y equals 3. So hopefully, as you see what's coming, the logic should apply to the same for x equals -2. Here's my point. At where the x value, at this point, I've got -2. As I go up with my y value changing this time, what's the x value? Well, it's -2. What about when y equals 2? What does x equal? Well, -2. What about when y equals -4? X equals -2. It's the same idea all along this line. X will always equal -2. In other words, it doesn't matter what y value you choose. Your x will always equal -2. So you can see that they plot as, in this case, vertical or horizontal lines. So, working in reverse, if you were given the line, what would the equation of this line be? Well, I can see that it goes through an x value of 3. Okay. And everywhere along that line, it doesn't matter what y value I pick, x is always going to equal 3. So that is the line x equals 3, the equation of that line. So you hopefully can see a little bit of a pattern forming here, is that before we go on to that, what about the actual axis lines? This vertical line here, which is my y-axis. Well, along here, it doesn't matter what y value I pick, x is going to always equal 0. And same with my x-axis. If I was to go along the x-axis, for any value of x, y will always equal 0. So the equation of the y-axis is x equals 0, and the equation of the x-axis is y equals 0. And here's the pattern that I started to talk about, but I jumped the gun a bit. If it's a vertical line, then it's going to be x equals something. If it's a horizontal line, then it's going to be y equals something. And you can see that from our examples. All the vertical ones have an equation x equals something. All the horizontal ones, including the x-axis, have the equation y equals something. And that something is simply where the axis gets cut. Okay, so for my vertical line here, my black one on our diagram, x equals 3. It's a vertical line, so I know it's going to be x equals. And where it cuts the axis is the bit that goes in here. So in this case, it's going to be x equals 3. That's it. They are the equations of vertical and horizontal lines.